Welcome back to another debate video between Draft Physics and myself, Franklin Hu. And we have been exchanging videos back and forth, and this video is in response to a video posted by Gary on his website called FU Franklin Hu. And you can guess what FU means. So I'm not quite sure why he didn't post this on YouTube, perhaps because it was filled with profanity, perhaps. But I just wanted to make a note that that's not a very professional response back. I find that between the dissident world is that when the only answer that people have back to your arguments is to basically insult you, that's basically admitting that they don't have anything else better to throw at you other than an insult. So hopefully we won't be doing that too much. And so, Gary, I know you're watching this, and this is going to be I would say, a direct attack upon your 2 plus 2 plus 2 physics. And I'm going to directly show you in this video, why is it I think that your theory is wrong. And I would like you to think that I'm doing this as a favor to you, because it's very hard to find people to debate with. No one will take up your $2,000 challenge to discuss these things with you. So, but between us dissidents, at least we can discuss things. That's perfectly fine. And so, I would like nothing better than for you to respond to this video by coming up with a similar video saying, what's wrong with pos-electron physics, right? You can go ahead and tear my theories apart, and I would just absolutely love it, right? Because I want to know why people don't take my theory seriously. You want to know why people don't take your theories seriously. And so I'm going to give you what I think those reasons are. Okay, so let's get into it. But I'm going to try and keep it short. I mean, it's hard to make short physics videos, but let's get into it. So back here, I have 3 points corresponding to your 2 plus 2 plus 2 physics, the three things that are in it, and what's wrong with that. Okay, so number one, so your whole theory is based upon the existence of the force bit. And so my first objection, and the objection I think most people would have, is, okay, Gary, what is the experimental evidence for your force bit upon which your entire theory is based? Okay, now you claim that, yeah, there's lots of evidence for the force bit. It explains charge and slits and all that other stuff. But no, actually, it doesn't. Because if you are just saying that it helps to explain existing data, that actually doesn't prove that the basis of your thing, the force bit, actually exists. I mean, I have my own theory, for example, and I could say the same things, that my theory also explains how a charge works, but that in itself is not any distinguishing feature between, say, my theory, which is based on phased waves, and your theory, which is based on force bits. So what exactly would count as actual direct evidence? Well, one thing that would count is if mainstream science already recognized the existence of your force bit as existing. So, for example, if they ran all these accelerator experiments and they're finding this other particle, which is not an electron or positron or any of the other particles they found, and if they saw that this particular flavor of particle only comes out of a proton, and this other particular flavor of this particle only comes out of electrons, then that would count as direct evidence that they're showing up similar to what you have here in your opening screen, where we see this, where you have this simulated, and we can see like the red particles coming out of the red objects and the blue particles coming out of the blue objects. Now, to prove the existence of your force bit, you would need to do an experiment which shows, okay, this is the prediction. Do an experiment where somehow you manage to take a picture that I can actually see these force bits in action. I mean, you're claiming they are matter, that they have a mass. So what is the mass of these force bits? And how can we actually isolate one of them or create perhaps a beam of them? I mean, that's one way to, one of the gold standards for determining whether a particle actually exists is whether you can actually form a beam of them. Then you can go run experiments. So you could have your beam of red particle bits and you have your beam of blue particle bits. And then you could go fire them at specific targets and show how those things are different. I mean, even the fact that you could create such a beam would be very strong evidence that your particle exists. But so, Gary, I ask you this. So suppose I gave you $1 billion in all the resources of MIT, Stanford, Caltech, and CERN combined, okay? Suppose I gave you all of those resources. Is there any experiment that you can propose that can actually, so we can actually see these force bits in action, right? It's not enough that your theories, are consistent with existing theories. You have to go and do a unique experiment, which uniquely shows that the result, that the charge is actually the result of, in fact, of these force bits, as you claim. Okay, so that is your homework. But I kind of suspect that no, it may be possible that these force bits are too small to ever be seen, or to ever be detected, or to ever really get down to seeing that. And now while that might be the case, that's not the best physical evidence that you could present to anybody. I mean, we'd be getting to like where we are with, say, string theory, and string theory has a similar thing where this there's no experiment that can see the strings at that scale. In which case, I don't think that we're talking science anymore if you can't actually verify the basic fundamental assumptions of your theory. Now, I was trying to explain before that you can do that, but the things that you're fundamentally assuming have to already be accepted by mainstream science. So, for example, if your theory is based on just the existence of electron, I mean, that's fine. If everything that your theory relied upon electrons, then there would be plenty of direct evidence for the electrons, and that would be perfectly valid. However, that is not the case with force bits. These things are not recognized by mainstream, and I think if they did have characteristics of matter, that our accelerator experiments would have seen them. I don't know how they could have escaped. I mean, they've collided everything with everything else, with every kind of detector, and we have not seen anything which corresponds to the force bit, right? So that would be the first reason why no one will take your theory seriously, because it starts with the invention of something that we're pretty sure doesn't exist, or hasn't been found, or can't be found, right? Those are some pretty serious reasons not to believe 2 + 2 + 2 physics, right? Okay, now let's get on to our second thing. Now, so that's against the two force bits. That's the first two. So the second two is the two kinds of interaction. Now, as I had demonstrated in the previous video, we are expected to believe that, we have these different colored particles. One of them is a proton. Proton, we'll color that with a red circle, and an electron. Now, this can be any color, but I think the red and green show up nicely here. And that we have the force bits, which are also red and green. And you let me know whether I'm not explaining this correctly. But the thing is that the basic property you have assigned is the thing that when the green bit goes into the red particle, it will somehow become the opposite particle, which is the red particle. So it comes in here, it does something weird, and then boom, it becomes a red. That's exactly how you explained it in your video, okay? Now, I think we both all agree that that we're trying to get this down to, say, Newtonian physics, all right? Now, there's nothing in Newtonian physics that says that you can take any kind of particle of some property and then have it magically convert into another particle of a different property, right? That's not what Newtonian physics is about. Newtonian physics is just about, this particle hits that particle and pushes it that way. That's Newtonian physics. Newtonian physics is not about, this particle hitting that particle and then turning it into something, completely different. That's not what Newtonian physics is about. Newtonian physics is only about the collisions, right? So this is a problem that, what you've done is that you're trying to explain the problem of how charge works, which is, why is it a proton is attracted to an electron, right? So let's say here, there's electron, and then we have, our proton. Fundamental question, why are those two being pushed against each other? Now, let's suppose we believe your two interaction is true. Okay, so let's suppose the entire world has believed that. But then the question will become, well, Gary, how is it that the red bit coming in here turns into the green bit? That's still going to be a question, and that's still the fundamental reason why we get this interaction of the bits hitting the positron electron. So all you've done is you've taken one question, which is, how does charge work, and turned it into another, which is like, how does one force bit turn into another? So exactly how does that help us, right? You've taken one difficult to explain problem, and you've kind of helped explain why they're getting pushed together, because we can now see that there are particles that are hitting this thing, and sometimes they react by actually pushing, and then sometimes they don't. So that the reason why they're being pushed, they're coming is because they're being pushed. That kind of helps, but fundamentally, the world would still be left with yet another question, which is non-Newtonian, which is how one force bit turns into another. So that is a question which will still have to be answered by you, and is just as mysterious as the original question, which is why positive charges attract negative charges. The only way you could solve this is if you actually got it down to a fully Newtonian explanation, where you just said that the reasons why the proton is attracted to the electron is because there's more things just pushing on this, and there's more things pushing on that, and there are fewer things pushing in between, right? And that doesn't require any particles to convert themselves into anything. It just has to be just more stuff pushing this to push them together, and that would be a Newtonian explanation. Now, I did explain, how, say, I explain this, and that's exactly how I explain it, is that just briefly, just as a comparison to how you can get this interaction. Now, you said that, how can I explain that these things are different without them being different? Well, they are different, but the difference that I selected was a difference of phase, right? Now, you mentioned something very similar, which is like, say, polarization. But the thing is with phase is that you can have exactly the same object in space. So, my claim is that the positron and the electron are in fact exactly the same object. They're both, electron-like particles. The only difference is that these things are putting out waves. And the only difference is that these waves are out of phase. So that when they come together, they cancel. And when they cancel, that means that the forces that are between these two can't affect each other, and thus all the forces on the outside still are working. So all of these forces are still working, but the forces in between are not. I mean, I would explain that with like my hands. So let's say this is the waves that are coming from the proton, and this is the waves that are coming from the electron. Now, if they're out of phase, that means that when the proton pushes, the electron backs up. And when the electron pushes, the proton backs up. So between the two, it's like I can't not exert any force against my hands while they're doing that because they're out of phase. Now, the thing is, if they are in phase, like I've got two protons, then when they come together, it's going to be like that. My hand is going to be able to hit the other hand because it's not backing up, right? And if they're in the same phase, they're actually colliding into each other. So this is why the waves which are in phase can exert a force versus the waves which are out of phase, which can never actually touch each other, right? So notice, Gary, I did not use any non-Newtonian explanation in that. And that's just a matter of collisions and using phases. And we know how phases work. This has in fact been demonstrated in an experiment 100 years ago using water and pulsing balloons, and showed that, yes, this does actually create an attractive force. And that is an experimental confirmation of this idea. So you don't have to take it on faith that this sort of thing might occur, because people have done experiments and shown that it does work. And unlike yours, nothing is converted here. This is just collisions of waves, which is just collisions of particles, which is fully Newtonian, right? So this is how we can explain, say, your two interactions without creating another problem, which is, how do the one force bit turn into the other? That's you got to have an explanation that doesn't lead you to another thing which is even harder to explain. So that is my criticism against the second two, which is the two kinds of interactions. Okay, the third objection we have is that you only have the proton and the electron as the objects in the universe. But clearly, the proton is a composite object, and the positron does exist. So, yes, I would have to say that the evidence for the positron is extremely strong. Now, Gary, the only evidence you have posted so far is, ancient pictures of cloud chambers, right? And I would have to agree to you that cloud chambers is not a very convincing picture, and that you could be confused. You don't know how fast these things are going, and so it's kind of hard to tell what the mass is, etc. Okay, so I'm going to go and point out a few other things that should convince you that positrons do in fact exist, and I'll leave these links in the description here, but you really should go and take a look at those and convince yourself that positrons do exist. Because when you say stuff like positrons don't exist, you're just losing a lot of credibility. I mean, mainstream scientists, especially all the people who've been working in CERN, and all they do all day long is play with positrons, electrons. They're just going to completely discount you. They're going to say that guy. I mean, you might as well say electrons don't exist. It's that bad. Okay. Now, the thing that you should know is that, say, if protons and positrons were the same thing, then there's no experiment that you could perform to show that they are different. But they are different. And for example, one of the differences is how you create, say, a beam of protons versus a beam of positrons. Physicists have to do this. And the way you create a beam of protons is simply you strip the electrons off of hydrogen, right? Hydrogen is just a proton with an electron flying around it. So to get a beam of protons, all you have to do is strip the hydrogen off and then accelerate that particle. And that is exactly what particle accelerators like at the Large Hadron Collider does. They actually have a little bottle of hydrogen, and that is how you create a proton beam. But creating a positron beam is very different. Typically, you have to fire uh, like lasers through a gas, or there are certain isotopes which are radioactive, which naturally emit positrons, or you have to fire an electron beam against, say, a tungsten target. And those, I mean, and it's very difficult to do, any of these things. Now, if positrons were the same as protons, then you don't, why would they bother going through that much trouble if they could just strip the electrons off of hydrogen? And the reason is that you don't get positrons that way. That they are experimentally very different objects. They have to be created experimentally in very different ways. Now, the other thing that is very convincing about the existence of the positron is that it doesn't react at all the same as a proton. Okay, here's the key: when you get when you generate a positron, when it meets an electron, it's going to do something a bit strange. Now, conventional physics says that an annihilation occurs and both of these particles disappear, and what comes out is a gamma ray, okay? Gamma rays come out and the original particles disappear. Okay, now I told you we know how to generate beams of these things, and this is what happens when a positron meets an electron. It turns into gamma rays, okay? Now that's very different than what happens to when a proton meets an electron. What happens? Well, what happens is that the electron goes into orbit around the proton and it becomes hydrogen. Okay, just regular. That's what hydrogen is. I've been trying to tell you. Okay, you take an electron, you put it with a proton, you get hydrogen, and you can do all kinds of experiments with it to prove that that's what that is. Just hydrogen. No gamma rays are released in this process. None. And that's very important because entire medical industries have been built upon the existence of the positron. There's a thing called PET scanners, positive emission tomography. And the way that works is that they inject a radioactive tracer into your body. That radioactive tracer emits positrons, not protons. Positrons. Why positrons? Because when they interact with your body, they emit gamma rays. Those gamma rays are detectable by the sensors, and then they can image what's inside your body because of what they're seeing from the gamma rays, which are being emitted by your body because of the interaction of the positrons with the electrons in your body. Now, if this was like, if there was no difference between positrons and protons, then, they could easily send a proton beam into your body, which would be a lot easier to generate, right? I don't think they would have to inject the radioactive substances into your body. They just generate a proton beam, and actually, that's another kind of medical device which they already have, which is they have proton therapy. And once again, they just strip the electrons off the hydrogen, and they do this proton therapy, and it's good for killing cancer cells, right? That's very different than a positronic beam, right? Okay, so another thing that you need to consider is that the detectors in use now are very much not your father's cloud chamber pictures like you were showing. So like we have at the LHC, the way these detectors work is they have layers upon layers upon layers of silicon detectors. When the particle comes through, they know exactly what the velocity is because they can see it at every single layer. And they have very careful timers. So yeah, they can exactly tell what the velocity is. They know exactly what the magnetic force is. So they can completely eliminate the confusion about between the trading off mass between velocity because they can tell velocity quite precisely. And like I said, the other funny thing is that the scientists at the LHC, that's pretty much all they do, which is they go around, they recognize the positrons, the electrons, they try and reverse engineer the reactions where they came from to try, say that the Higgs boson was there. But to say that like half the things that they're looking at are, protons, it would be absurd because protons would definitely look different and have a definitively larger mass than the positron. The other interesting thing about that collider is that before they put in the LHC, the Large Hadron Collider, they had the LAP, the positron electron collider, right? So if positrons and electrons were the same things, why would they spend, I don't know, a couple $billion changing their accelerator to collide protons when they're arguably they were probably, according to Gary, they must have been shooting protons before. But no, they were not shooting protons. The previous LAP collider, the positron electron collider, was generating and colliding positrons, and they wanted to have a bigger particle. So that's why they have the Large Hadron, because protons are large and they can even collide things like lead ions. Get the bigger thing colliding together because the positron is the smallest possible thing you can collide. So those are the things, Gary, I think you should look at when you want to, say that the positron doesn't exist. Because like I say, I mean, the worst thing is that you just immediately lose credibility amongst almost everybody when you say positrons don't exist. When, quite clearly, like an entire medical industry relies on them doing that. They generate the gamma rays, right? There's no way proton can generate gamma ray. No way. So I would have to say, yeah, slam dunk on the existence of the positron, right? And that should also serve as an example for, how people directly provide direct evidence for things that do exist. And so if you want people to believe your theories, then you're going to have to come up with similar kinds of evidence, right? So I think I'll stop that here. Maybe I'll make another video directly just flipping through the video and responding to individual points. But this particular video is simply about, the reasons what's wrong with 2 + 2 + 2 physics and why that doesn't work. So until then, ta-ta.